The expectation is that you guys know the names of polygons, right? So you should already know all these through 12. Then after 12, it's just an n-gon. So like if it had 20 sides, it'd be called a 20-gon, and so on, right? So those you should know. All this information, you should know all that. So a polygon is a closed figure. It's made up of segments and angles. There's no circular sides on a polygon. Equilateral polygon, all equal sides. Equal angular, all equal angular, or all equal angles. And then for it to be regular, it has to have equal angular with equilateral. A diagonal. So when we talk about diagonals, if I draw a quadrilateral here, a diagonal is defined by going from one vertice to a non-adjacent vertice. So how many lines or how many diagonals could I draw from this vertice to a non-adjacent vertice?
No.
Yeah, just one. It could only go here because this vertice would be adjacent and this vertice would be adjacent, and those would be sides, not diagonals. Okay? So this guy only has one diagonal. Convex is out, concave is in, so a concave, so this would be considered a concave figure because it caves in like a cave, right? Okay, so those are things that we should already know. So now let's go down here to 8.1, and that was back in Unit 1, actually. So the interior angle sum theorem. So we can figure out how many degrees are in any polygon by using this formula. The formula is n minus 2 times 180. N is the number of sides on the figure that we're talking about. I want to explain why this works. Okay? Let's take that quadrilateral again. So we have a quadrilateral. I'm going to talk about its diagonals. How many diagonals did we say that this quadrilateral has? One. Okay? When you draw the diagonal, what figures have you actually made? I've made how many triangles? 2. How many degrees are in a triangle?
180.
180 and 180. So if I use this formula, what's my n in this situation? 4, because it has 4 sides, minus 2. What's 4 minus 2? So you're actually doing 2 times 180. 2 what times 180? 2 triangles. What you're actually doing in this formula is figuring out how many triangles make up that figure. And it's always 2 less than the number of sides. So if I had a 5-sided figure, a pentagon, how many triangles would be in that pentagon? There would be 3. And each of those triangles has how many degrees? So that's why you're doing the n minus 2, the 5 minus the 2. That leaves me with 3 triangles in that pentagon. Each of those triangles has 180 degrees. So that's where this formula is derived from. Does that make sense? Okay. So go ahead, and I want you to try number 1 and number 2 on your own real quick. Do means 2, dec means 10, so that together makes 12 sides. So you're going to plug it into that formula of the n, so that'd be 12 minus 2. So that gives me 10 triangles, and each of those triangles is 180 degrees, right? So how many degrees total are in this figure? Good. The sum of measures of the interior angles of a convex polygon is 2,520. How many sides does the polygon have? So you're going to go backwards on this one. So you're going to take that formula of the n minus 2 times the 180, and now we know that it is equal to 2,520, and you're going to solve for the number of sides. Does that make sense? Okay. What did you guys do first on this one? What? Yep. You need to divide both sides by 180. So I get n minus 2 equals how much? 14, and then I add 2 to both sides. So how many sides is this? So what do we call that guy? Yeah. Yep. All right, number 3. What am I going to do to find the value of x? So they've given me all these angle measures. Some of them have x's with them. Some of them are just regular angle measures. What are you going to have to find first on this guy? Yeah. Okay. So what is that? How'd you get that? Okay, so we know there's 7 sides on this figure. We're going to subtract 2. That gives me 5 triangles times 180 degrees each. So this figure total has 900 degrees. Okay, so once I know how many degrees are total inside this figure, and it's 900, what do I do to start solving for x? Yeah. It's what? Okay, how many degrees did you get when you added all those? So 900 minus 530 gave us 370. Okay. And then what'd you do? So 74x equals 370, is that right? So then you divide by 74, divide by 74. What do we get x to equal? Okay. Any questions on those? Okay, next page. Exterior angles theorem. So what this guy states is that you could have a triangle, you could have a decagon, you could have a 20gon, you could have an infinite gon. It does not matter how many sides a figure has. Its exterior angles will always add up to 360. Okay? And when we talk about exterior angles, remember it goes around in a circle. So like this is an exterior, so if we're talking about extending this line on that exterior, then we have to extend this line. That's an exterior of this. See how it goes along, around in like a windmill fashion? So all of those that I just put a dot in should add up to 360. And again, it doesn't matter how many sides there are. I want for you to try number 3 on your own, solving for x, y, and z. Remind me real quick, how many degrees are in a straight line? 180. Okay. Okay. Let's look at number 3. What should I or can I do first? Yeah.
You need to add up all of the given degrees of the angle measures and find the other ones so that you have all of them.
Okay, how do I find the other ones?
You subtract the given angle measure of the inside from 180, and that gives you the outside.
Okay, so you're talking about like this one right here.
Yeah.
So these two together make a straight line, so that it adds up to 180, right?
Yeah.
So I do 180 minus 134, and how much do I get? 46. Okay, someone new, tell me how many degrees are out here then? 98. Can I do it for any others? No. Okay, so now what do I do? Okay. Good. So how many x's did I get? And then I have 98, 46 is 72, which equals how much? And that should always equal how many degrees? So I'm going to take 360 minus 216, so I get 6x equals, what is that, 144? Divide by 6, and x equals how much? Okay. So now I found x. How do I continue finding other variables? Yeah. Okay, so if I plug in to x here, that's 24. So I'm going to do 180 minus 24 to get y, is that right? How many degrees is y then? Okay. If I plug in 24 here, I get 48. Subtract that from 180, and what do I get for z? I could plug it into this guy. Do I have to? No, because they're not actually asking me for this angle measure, so wouldn't necessarily have to. Very good. Number 4, solve for the value of x. Similar but easy, I think. Easier on this one, right? How do I solve for this guy? Good. What is 93 plus 75? Okay. And so then I'm going to subtract 168 from both sides. I get what? 192? Is that right? So 3x's equal 192. So what does x equal? And that's all they wanted us to find on that one. Perfect, right? Are we doing okay so far, guys?
Yeah.
Okay. 2 more small things. Interior angles of regular polygons. So the difference here is we're talking about regular polygons. Okay. they're wanting to know the specific interior and exterior angles of regular polygons. So if it's regular, what does that mean? Angles in the sides are the same. So we're going to start with exterior. Exterior is just slightly easier. How many degrees are always on the exterior angles? 360. Let's say I have a decagon. How many sides does a decagon have? 10 sides on a decagon, and it's a regular decagon. So what does that mean about its angles? They're all equal. So if I have 360 degrees on on the exterior angles of a decagon, and I know it's a regular decagon, what's going to be true about each of those exterior angles? They're all going to be equal. So how would I figure out how many degrees are in each of those angles on a regular decagon? In that case, 10, yes. So you're just doing 360 divided by the number of sides it has. And this only works for regular because the regular has all equal sides. Interior angles, not much different or not much more difficult. How do I find first how many degrees are on the inside of a figure of a polygon? Okay, n minus 2 times 180. So the number of sides it has, take off 2 and then multiply it by 180. Let's say, again, this is a decagon. And it's a regular decagon. What's going to be true about each of those interior angles? They're going to be equal. So if this is how I find out how many degrees total are on that figure, how would I figure out then how many degrees are in one of those angles? Divided by 10, or in general by the number of sides, right? Does that make sense, guys? Okay, so knowing that, try number 4 on your own. You want to find interior and exterior. Interior angles. It's a 16gon, so it has 16 sides. How would I set this guy up to solve? What would I do?
16 minus 2 over 16.
Yeah. So when you put this into your calculator, make sure to do the whole thing on the top, press enter, and then divide by 16. So that's 14 times 180 divided by 16. How many degrees did you guys get?
For the entire
For the entire thing, and then divide by 16, what do I get? 157.5 degrees. Okay. How do I find exterior angles on this guy? Good. How many degrees is that? What do you guys notice about these two? They equal 180. And shouldn't they equal 180? Because the interior plus the exterior make a what? Straight line, so it's 180 degrees. This is only if all angles are equal, because we're talking about a regular polygon. So if it's regular, then they're all equal, yes. So if it doesn't say regular, then you can't do this. Number 5, each interior angle of a regular polygon has a measure of 140 degrees. Classify the polygon by its number of sides. So if I know that each interior angle is 140, do I know how many total degrees are on the inside of this figure? No. So that doesn't help me in the sense of finding the number of degrees. Like I can't say, okay, each one's 140 times 8. It has 8 sides because we don't know how many sides. But what I can do on this is I can find its exterior angle and then figure out how many sides it has after its exterior angles, because exterior angles never change. It's always how many degrees out there. 360. So if an interior angle has 140 degrees, how many degrees would its exterior counterpart have? 40. You would do that 180 for the straight line minus the 140 that's on the inside, which would leave us with 40 degrees on the exterior angle. Okay. So that means on this regular polygon, every single exterior angle is 40 degrees. What else do we know about exterior angles? They add up to 360. So if I know that some figure has 40 degrees in all of its angles, and all those angles have to add up to 360, how am I going to figure out how many total angles it has? Yep, we just divide it. 360 divided by 40. And then how many sides is that? What's a 9-sided figure called? Yep. Perfect. Homework for today is just the practice C and the supplemental practice on 8.1. Any questions for me?